So what we're gonna try to do is find the moment of inertia of a hollow cylinder. So this is our drawing here. What we're gonna do is we have to take the integral of this formula, which is the integral is r squared dm. So what we're gonna do is we're gonna take a piece from our cylinder, we're gonna bring it out. We're gonna label our height as L. And what we're gonna do is our length would be 2 pi r, and our width would be dm. So what we're gonna do is try to find something as close to the dm.
Not dm.
dr. We're gonna try to find something close to the dm, which is that has to do with the mass of the cylinder. So what we're gonna do is take the dm. Pause. God, I forgot. So then what we're gonna do is our dm is gonna equal to rho. And then we're gonna take the dV, which is the density and the volume of the piece that we took from the hollow cylinder. Our dV, we're gonna use the height and the area of the piece that we just took out. So it would be dV is equal to L times 2 pi r and our dr. So now what we're gonna do is get our dm, which is gonna equal to all of this, our rho L 2 pi r dr, and we're gonna plug this in back into this equation. So it'll be. So now that we're gonna plug in this dm back into our equation, the limits are little r and big R. So we're gonna have r squared dm, which is dm is 2 pi r L dr. So now what we're gonna do is, we know that these are constants. We're gonna bring them out. We're gonna integrate it. So it'll be 2 pi L, and we're gonna have r squared times r. Pause it.
Go.
So then it'll be dr, and we have to factor out the rho outside. So it'll be r cubed dr. So what we're gonna do is we're gonna integrate this, which would be the s, the 2 pi L rho, and this will be 1/4 r to the 4th with the limits of big R and little r. So what we're gonna do is we're gonna incorporate the limits now. So it'll be 1/4 r to the 4th minus 1/4 little r to the 4th. Now we're gonna have, pause it. Okay, because we know that rho is equal to mass over volume, what we're gonna do is plug in for our volume, which our volume is pi L r squared minus little r squared. So when we do that on our mass, it'll be this over pi L big R squared minus r squared over 2, this will be on the side of 2 pi L. This remains the same. The pi's would cancel, and so, not the 2. The pi and the L would cancel. So you'll be with m multiplied by 2 over r squared minus little r squared. So when we're left with this, we want to make this, we're going to factor out 1/4. We're going to factor it out. So we'll be left with, because when that gets factored out, you'll be left with 1/2. So the 1 is there. It'll just be 1/2 right here. So then, because we factor that out, it'll be R4 because we factor it out, what we wanna do is we're gonna combine these and simplify them. So it'll be r squared minus big R squared minus little r squared, and then r squared plus r squared, in order to cancel one of those out. So what we're gonna do is, it'll be 1/2 m, this will cancel, and you'll be left with r squared plus little r squared. And that would be our inertia, if I'm correct.